The scientific method is the systematic approach scientists use to explore the world around us and uncover the mysteries of nature. Let's take a look at the key principles and steps of the scientific method, providing you with a comprehensive understanding of this powerful tool. The scientific method is a logical and organized process used by scientists to acquire knowledge and answer questions through systematic observation, experimentation, and analysis. It provides a reliable framework for investigating the natural world and forming accurate conclusions based on evidence. The method consists of several interconnected steps, which we will explore one by one. Step 1. Observation. The first step in the scientific method is making observations. Scientists carefully observe and identify a specific phenomenon or problem they wish to investigate. For example, let's say a researcher notices that plants in a certain area are growing taller than plants in a different area. Step 2. Research. Once an observation is made, scientists gather existing information and conduct research on the topic. They review relevant literature, consult experts, and collect data to develop a solid understanding of the subject. In our example, the researcher might investigate factors like soil composition, sunlight exposure, and nutrient levels affecting plant growth. Step 3. Hypothesis. Based on their research, scientists formulate a hypothesis, a tentative explanation for the observed phenomenon. A good hypothesis is testable and falsifiable. In our case, the researcher may hypothesize that plants in the area with higher sunlight exposure will grow taller due to increased photosynthesis. Step 4. Experiment. The next step involves designing and conducting an experiment to test the hypothesis. Scientists carefully plan their experiments, controlling variables and setting up a methodology to collect data. In our example, the researcher may set up multiple plant groups with varying levels of sunlight exposure and measure their growth over a specified period. Step 5. Data analysis. Once the experiment is complete, scientists analyze the data they have collected. They use statistical tools and techniques to interpret the results objectively. In our case, the researcher would compare the growth rates of the plants in different sunlight exposure groups and determine if there is a significant difference. Step 6. Conclusion. Based on the data analysis, scientists draw conclusions about the hypothesis. If the results support the hypothesis, it may become a theory or accepted explanation. If the results do not align with the hypothesis, scientists go back to the drawing board and revise their approach. In our example, if the plants in the high sunlight group grew taller as hypothesized, the researcher could conclude that sunlight exposure influences plant growth. Step 7. Communication. The final step of the scientific method involves sharing the findings with the scientific community and the public. Scientists publish their research in scientific journals, present their findings at conferences, and engage in discussions with peers. This open exchange of information fosters collaboration and helps build upon existing knowledge. The scientific method is a continuous cycle of observation, research, hypothesis formulation, experimentation, data analysis, conclusion drawing, and communication. It allows scientists to refine their understanding, challenge existing beliefs, and contribute to the advancement of knowledge. In summary, the scientific method is a systematic and reliable approach used by scientists to explore and understand the natural world. Through careful observation, rigorous experimentation, and data analysis, scientists can uncover the secrets of nature and make meaningful contributions to society. By following this logical and structured process, scientists can confidently investigate phenomena, test hypotheses, and make evidence-based conclusions. Richard Feynman offered perhaps one of the best definitions of science and the scientific method in one of his lectures. If it disagrees with experiment, it's wrong. In that simple statement is the key to science. It doesn't make any difference how beautiful your guess is. It doesn't matter how smart you are, who made the guess, or what his name is. If it disagrees with experiment, it's wrong. That's all there is to it. Remember, the scientific method is not limited to the realm of scientific research. Its principles can be applied to various aspects of everyday life. For example, when faced with a problem or question, you can adopt a similar approach by making observations, researching, formulating hypotheses, testing them through experiments or practical trials, analyzing the results, and drawing conclusions. By employing the scientific method in your own life, you can make more informed decisions, solve problems effectively, and develop a deeper understanding of the world around you. It encourages critical thinking, curiosity, and a commitment to evidence-based reasoning. Whether you're a scientist conducting groundbreaking research or an individual seeking answers to everyday questions, remember the scientific method as a reliable tool to explore and unravel the mysteries of our fascinating world.